Well, good morning. This is 11:35. We're 5 minutes late getting started for linear algebra class. But unfortunately, I'm the only one in the room, so I'm going to go and get started, even though there's no other students here. I'm going to wait and make the announcements until someone shows up. If no one shows up by the end of the class, then I'll make the announcements then. But I want to make sure at least somebody's here to hear them. So let's pick up and go from where we left off last time. We're in Chapter 2, Matrices, 2.3, Inverse of a Matrix. And we were getting ready to do example 6. Okay? And it says compute a, let me get my pen set up. Okay? A to the minus 2. Okay? Two different ways and show that the results are equal. Well, here is matrix A. Matrix A is 1, 1, 2, 4. Okay. Now, there's two ways to do A to the minus 2. One way is A to the minus 1 and then square it, or the other way is A squared and then do that to the minus 1. Okay? So those are the two ways. So let's do the first way. Not any preference on which way. Since I wrote it first, let's do A inverse. So what is A inverse? Well, the quick way to do a 2 by 2 matrix is inverse, remember? Okay, first thing, take a determinant. Okay, so the determinant of A, and that's the symbol for it. We haven't gotten there yet, but that's the symbol for the determinant. It looks like absolute values, but it's really a determinant. And this will be 4 minus 2, which is 2. So A inverse will be 1 over 2, and then you reverse the main diagonal elements. 4, 1, negate the off-diagonal elements. Minus 1, minus 2. That's the inverse. So let's go on and write it out as, well, I think I would prefer it in that form right there. So the next thing is going to be to square it. So multiply this by 1/2 times 4 minus 1 minus 2, 1. Okay? Well, the 1/2 times 1/2 you can pull out front and make it 1/4. Okay? And then we're going to do the calculations here. Okay? Multiplying these two together, this is the same as squaring it. Okay? This first entry is the 1, 1 entry, so it's first row by first column. First row by first column. The 4 times 4 is 16, plus 2 is 18. Okay? And then 1, 2 entry here would be first row by second column. Minus 4 minus 1 is minus 5. The 2, 1 entry here is second row, first column. Minus 8 minus 2 is negative 10. And then the 2, 2 entry is second row, second column. 2 plus 1 is 3. So there's A to the minus 2, the first way we did it. Second way, first thing we do is multiply A by itself. So this would be 1, 1, 2, 4, multiplied by 1, 1, 2, 4. And that will give us a 2 by 2 matrix. And the 1, 1 entry would be first row by first column. That's 1 plus 2 is 3. The 1, 2 entry would be first row, second column. 1 plus 4 is 5. Okay. The 2, 2 entry here is second row. 2, 1 entry here is second row, first column. 2 plus 8 is 10. And the 2, 2 entry here, second row, second column, 2 plus 16 is 18. All right, so that gives you A squared. Now let's do the inverse of A squared. So do that to the minus 1. And again, this is a oh, okay. I was sort of got wondering why I was off some. Well, the reason is I forgot to take the determinant. The determinant of this thing here is, woo, big number here. That would be 3 times 18. 3 times 8 is 24. That would be 54 minus 50. So that would be 4. So the determinant would be 1 over 4. Ha, good. And then reverse the main diagonal, 18 and 3, and negate the off diagonals, minus 5 and minus 10. And look at that. Exactly the same thing as we got before. Okay? Precisely, exactly the same thing. Okay, now they didn't leave the 1/4 out front, which I find just easier to do, but if you want to multiply it through, which they did do, so let's show that our answers do the same. 1/4 of 18, that would be 18/4, which reduces to 9 halves, minus 5/4, minus 5 halves, 3/4. Okay, now let's see what they got. 9 halves, negative 5/4, negative 5 halves, and 3/4. Yes, each method produces the same result. Okay, so that was example 6, top of page 68. So the next theorem gives a formula for computing the inverse of a product of two matrices. We have actually bumped into this before in our little discovery things, but let's formalize it here by this theorem. If A and B are both invertible matrices. Now, time out. What does that mean to be invertible matrices? Okay, first and foremost, they both have to be square. You cannot have a matrix that's invertible that's not square. Only way it can be. Now, not all square matrices are invertible, but all invertible matrices have to be square. So we know they're square and that they do have inverses. Okay, and they're both invertible matrices of order n. What does that mean? That means they're square matrices n by n. Both of them. They have to be the same size or you can't do this. Oh my goodness. Am I ever shocked? Oh, whew. I thought I saw a ghost. Okay. All right. Tyrell is here. Okay. Thank you for coming. It is really boring talking to myself.
I believe it.
Oh, I see. You know the feeling? Is that what you're saying? I see. Okay. Yeah, hit me to the core. Okay, twist it a little bit there. Okay.
Because I have like to answer.
All right. Now, I also put off any announcements until someone came in to hear them because I knew if I just started talking to the computer, someone may never hear it. So I wanted to make sure at least one person did hear it. So here's the announcements I put off at the beginning. I'll tell you now. I don't know if you or anyone you know is in a first mini-term course, okay? If there are, please let them know, or you yourself, if that's the case, that student course evaluations are due in the first mini-term courses. Not the full term courses or second mini-term, you know, the second mini-term haven't even started yet, but the full first mini-term courses, those, and please do those, because those are really valuable to us as a school, to us as individual instructors, and to me as a department chair. I have to evaluate other instructors. It helps me to see what the students are saying. Okay. Okay, so please get that done. And if you didn't know, today is the last day of the first mini-term. Monday, Wednesday classes, their last day was yesterday. Today is for Tuesday, Thursday classes, today is the last day. Meaning, on Wednesday, second mini-term begins. So that also means just around midnight tonight, that's midterm. That's right in the middle, okay? And what they usually do shortly after midterm is request midterm progress reports. It's for us to report students who have a D or an F at midterm. They don't care about A, B, and C. They think those students are in good shape. But for D's and F's, they want to see if there's anything that can be done. Okay, now why am I telling you this? Well, this is for all the classes, but this one in particular, I have had one research paper turned in and one first test turned in. So that means the other 6 students, is that right? Other 5 students in the class, 1, 2, 3, 4, 5, in the class have 0 scores in at midterm. And guess what I'm supposed to turn in for them as a midterm progress report? You know, not a good one, okay? So I'd really love to have, by Thursday, either your research paper or your first test, or both, either one, just so I have something that I don't have to turn in a bunch of names at midterm, on the midterm progress report. So please get those done. Now, to follow that up a little bit, I don't know when they're due. They usually give us about a week to do them, which would put it till maybe next Tuesday or Thursday. But I haven't seen when they've set the deadline. Not that it's hard and fast or anything, but, you know, but just to let you know this. If they do set it for this Friday, which is a possibility, I'm not even going to be on campus on Friday. I've got a meeting, of all places, down in Mobile.
Wow.
Yes, on Friday. And that means I'll leave the house as close to 7 o'clock as I can in the morning, drive 4 to 5 hours to Mobile. I'll be there from 12 to 3 for my meeting, and then turn around and drive back 4 to 5 hours to get back to Birmingham, probably getting in around 8 o'clock at night. So I will not be on either campus on Friday. I'll be on the road or in a little 3-hour meeting or on the road, okay, the entire day and plus, okay. So that's a 13-hour day for a 3-hour meeting. That's strange. And I won't get anything done either, you know, because I'll be driving or in the meeting. So anyway, it'd really be good to have them by Thursday. But if you can't possibly have them by Thursday, then Monday or Tuesday would be okay. I think. I don't know what the deadline is, but I'll try to hold it off, fend it off until then. Okay, there's that. Oh, just for future reference, next Friday, I have an eye appointment right across the road here. I thought it was going to be Eye Foundation Hospital in Birmingham, but they said, nope, he's over on UAB West on this coming Friday, not this Friday, you know, but the Friday after this.
That'll be our, is that our spring break?
That is the last week, I think, before spring break. Let me see. Next week will be the 11th through the 14th. But I think we got one more week, don't we?
I thought it was the 20th.
Oh, is it? Okay. Yeah, it may be.
Yeah.
Okay, I'll have to check and see. It's either the Friday right before spring break or only got one more week after that. Yeah, I think it's Friday. I think you're right. Because that would be 3 weeks in March. That'll be the 4th week. I think that's right. I think the 4th week in March is the spring break week.
Yeah.
No, wait. This is the first week in March this week, okay? Next week's the 2nd week in March.
Right.
Then we have the 3rd week, and then spring break. I think it's the 4th week in March, isn't it? Or is it the 3rd week?
I don't know. I thought it was the 3rd.
Okay, it may be. If it is, then...
The 4th week, we have like a couple of days in March, right?
No, that is the 5th week, because we have 4 full weeks in March, and then a little bit of another one. I think it's that 4th full week.
Okay.
I'm not sure, but I believe it is. The week that ends on the 29th or something like that.
Okay.
Yeah. Okay. So I think we have one more week after that. Okay. All right. Let's see. Any other announcements? That's all I can think of for now. Seems like there may have been something else. Oh, just for today's reference, I'm taking my physical science class, the one that meets at 1:15 in here, We'll be leaving at 1:15 to go to Channel 13 for a field trip, weather and climate, and then we're coming back here and wrapping up the term. So from 1:15 until probably 2:15, 2:30, something like that, I won't be on campus at all. Then I'll be back and we'll have our class, but the class usually goes till 5:45. It won't go that late today, but I hope not anyway. But the whole class won't be here that long, but some who are making up work may be close to that long. But anyway, that one time period I won't even be on campus. Okay. About 2 hours or something like that. All right, that's all I can think of for now. All right, any questions before we get going?
Not at all.
Okay. This was Theorem 2.9 on page 68, the inverse of a product. So here's where we start. If A and B are invertible matrices, now what do we mean by an invertible matrix? What is one thing that has to be true? As soon as you see it's invertible, you know one thing about it. Got to be square. There's no way you can have an invertible matrix that's not square. So you know it's got to be square, okay? And they say of order n. That means it's n rows, n columns, n by n matrix. And they have to be the same size for this theorem to make any sense. So they're both n by n matrices. Okay. And if that's the case, then the conclusion of that is the product AB is also invertible, okay? If the two matrices are invertible and they're the same size, then the product that you can do, because they're both square matrices, n by n by n by n is going to be an n by n, the product is going to be invertible as well. And here is the big news of that result. If you do AB, the product of those two, and then invert that, another way you could have done it was do the inverse of B multiplied by the inverse of A. Bizarre but true. Not A inverse B inverse, but B inverse times A inverse. Okay? That is true. And like I said, a little bit earlier we did one of those little discovery blurbs, and we showed this for a certain 2 by 2 matrices. And it was fairly easy to show. And indeed, this was the case. This is the case for any two square matrices of the same size. Okay. Now, the proof is not hard, so let's just show what it is, okay? First, you know that A and B are both invertible matrices, and they're both the same size, so you can multiply them. Okay? So, if you take AB, the product of AB, you know you can do that, and multiply it by what we claim to be the inverse, which is this. We said the inverse of this is B inverse times A inverse, right? Now, what you can do here is group these separately, differently, as A times B, B inverse, times A inverse. Well, what's B times B inverse? Remember we said A and B are invertible matrices, so you know that B has an inverse. And what is a matrix times its inverse? What does that always result in? So it's certainly going to be square, a very specific square matrix. If you multiply a matrix by its inverse, or the inverse times the matrix, either way, you get the identity matrix of that same size. Right. It's just, yeah, it's just like when you take a function and its inverse and operate on one with the other, you get the x. You just got the identity function then. You have x. Here you get the identity matrix, which is I. So now you have I times A inverse. Okay? Well, what is I times A? That's just A. Times A inverse. Well, what's A times A inverse? because they're invertible matrices? It's I again. Okay? Well, here you multiplied the product by this thing, what we claimed was the inverse of it, and you got the identity matrix. So therefore, this must be the inverse of this. The inverse of that. So we've shown it's the only way. Only way. And then you can do it multiple times for any number of products. But you always have to do the reverse order. This one was for 2, but if you had a whole bunch of them, I think I will go to a clean screen. Do you have all this? Okay, I'll let you finish. Got it? Okay. And now I'm going to extend this to more than 2. Okay? So let's say we have a bunch of matrices. A1 multiplied by A2 multiplied by A3 multiplied by ... times A, what do they go to? N? Well, they just love using it. Okay? But we want to find, and all these are invertible matrices, by the way. They have to be. Okay? So all these N matrices are invertible, and they're all the same size. Okay? Well, if they are invertible, here's what the inverse is. The inverse of this would be A sub N inverse times A sub N minus 1 inverse times A sub N minus 2 inverse. Yuck. And here he is, Mr. America. Okay.
Always here. Either in spirits or in man.
What's that?
Say the one that's always here, either in spirit or in man.
Oh, okay. Yes, of course. Okay. So here's the extension of multiplying a number of invertible matrices together, as long as they're the same size, and then taking the inverse of that product. That's equal to the reverse order of their inverses, ... down to A sub 3 inverse times A sub 2 inverse times A sub 1 inverse. Okay? Okay. So any number of square matrices, same size, square invertible matrices, same size, you can multiply them together one way, take their inverse, or multiply the inverses by the reverse order, and they'll give the same results. So, I'll let you finish writing that. You got it? We'll go to example 7. Oh, goodness. Oh, I've already given the announcements in there on this, but you may not go and listen to them since you got here. Today is the last day of the first mini-term, which means midnight tonight is midterm, okay? And second mini-term starts tomorrow. So if you are in a mini-term course, I don't know if you are, or if you know someone who is, remind them the student course evaluations in that first mini-term course are due. Please get those done. Okay. Second issue, since tonight at midnight is midterm, right dab in the middle. Sometime after that, they usually ask for midterm progress reports, which means we have to report students who have D's or F's at midterm. And of the 7 people in this course, 1 has turned in a research paper, and 1 has turned in the first test. The rest have turned in nothing, okay? And therefore, if that's all I have at midterm, I have to turn in that you have an F at midterm. I don't want to do that. So get me something, either your research paper or your first test. Get it into me, if possible, by Thursday. I haven't seen if they've requested these yet or when the deadline is. They usually give us a week. So if they do give us a week, I might be able to still take it next Tuesday. I don't know what they're going to give us, but anyway, sooner the better. Okay. Secondly, I will be out of town on Friday, so I won't be here to get it on Friday. I've got to drive down to Mobile for a 3-hour meeting and drive back again. So I've got a 13-hour day coming up on Thursday for a 3-hour meeting. That sounds like a lot of fun. Okay. So, what's that?
Paid by the college?
Well, I'm required by the college to go. I get paid because they pay me, not anything extra or anything else. I just get my regular salary because I'm supposed to be there. And on top of that, I can't get any grading done on Friday because I'll be driving or in a meeting all day long. I might get some graded that night, but not much. So please get me stuff by Thursday if possible, or the very latest by next Tuesday. Okay. Oh, and the following Friday, even though I won't be on campus at all this Friday, I have a doctor's appointment, eye appointment, next Friday at 8:15, right across the road here at UAB West. And so I hope to be through with that by 9:15 or a little later, and then I'll be driving back to the Birmingham campus after that. So normally there by 8 o'clock on Friday morning. I'll be over here by 8 o'clock, going to my eye doctor appointment, and then driving over there as soon as I can get there, which I doubt if will be any before 10, okay? Maybe a little before 10, shoot for around 10 o'clock. All right, now example 7. It says find AB inverse. That's what we're looking for these two matrices. Here's A. 1, 3, 3. 1, 4, 3. 1, 3, 4. And B. 1, 2, 3. 1, 3, 3, 2, 4, 3. All right. Now, nothing here. Okay, number 1, both of these are square matrices, so that at least they have a potential of being invertible. But there's nothing that guarantees these are invertible matrices. I can look at them and tell you, I'm pretty sure I think they are, but I can't swear to it. 3 by 3s are harder to tell. 2 by 2s is real easy to tell. 3 by 3 is a lot harder. So, no guarantee, but we assume that they are because they told us to find the inverse of the product. Okay? Now, you have 2 ways you could do it. You could either multiply these 2 together and then take the inverse, which of course that's the direct way, or according to what we just did, you could do the inverse of B and then do the inverse of A and multiply them in that order. Well, guess what?
So you can either do the inverse first, then...
No, multiply first, then do the inverse of the product.
Or do the inverse, then multiply.
Okay, yeah, or do the inverse of that one, inverse of this one, and then multiply. But frankly, inverses are the longest process for a 3 by 3. 2 by 2 inverses are easy, okay? 3 by 3, that's a longer process. So I think I only want to take the inverse once rather than inverse twice and then multiply. This is multiply and then take the inverse once. So I'm going to favor this one. So let's first do the product of AB. Yep, it's going to be a 3 by 3 for sure. We know that. Okay. So where do you begin? First row, column 1. Okay, got it? 1 plus
3
is 4 plus
6
is 10. Okay. First row, second column. What you got?
We have
2.
9
That would be 11.
plus 12.
Right? That would be 23. Okay. 1, 3. First row, third column.
We got 3.
Right?
We got 9.
Plus 9 would be 12.
Plus 9 again.
Right? Is that 21?
Yes.
Okay.
Do that, and
All right.
Adding after the multiplication.
All right.
Alright. We got
The 2-1 entry.
2, 1. We got
1
we got 4.
plus 4 is 5.
We got 6.
Yep. It's 11, right?
Yes.
Okay. 2, 2.
2, 2. Yes. We got 2.
2.
We got 12.
That would be 14.
We got 12.
So that would be 26, right? 12 and 12 is 24 plus 2. 26, is that right? Okay. Then the 2, 3.
We got 2.
3.
We got 3.
3.
We got 12.
That would be 15.
We got 9.
So that would be 24, right?
Yes.
All right. 3, 1.
3, 1. We got 1.
Right?
Got 3.
That would be 4.
And we got 8.
That would be a 12. Right? Okay. 3, 2.
3, 2. Alright, we got 2.
2.
We got 9.
That would be 11.
We got 16.
16 would be 27. Right? Okay. 3, 3.
3, 3. We got 3.
Uh-huh.
We got 9.
That would be 12.
And we got 12.
So that would be 24. All right. So there's AB. Now the bad news is we got to do the inverse of that. Okay? So what I'm going to do is lose that, and we're going to do the inverse of this. And how do we do that? 1, 0, 0, 0, 1, 0, 0, 0, 1. You adjoin those two together. Now the bad news. There's no 1 anywhere in sight. The best and only thing I would do first is divide this row by 10, which means I think I'm going to deal with fractions now. I mean decimals now rather than fractions. So if you divide that row by 10, so row 1 divided by 10, or 1/10 of row 1, that would be a 1, 2.3, 2.1, 0.1, 0, and 0. Okay? Now, I'm going to write these others down. 11, 26, 24, gripes me no end. I'm getting my numbers out of line. Here it's really important to keep your paperwork neat as you can, especially the bookkeeping part. 26, 24, 0, 1, 0. And the bottom one is a 12, 27, 24, 0, 0, 1. Okay. Now, going to use the top row. What's our procedure here? What are we trying to do? Yeah, you want 0, 0 below. Perfect. So let's do that. So what we're going to multiply by what? And add to what?
11 times row 1.
Okay. No. Yeah, 11 row 1. Now I would say minus 11 row 1 plus row 2 is the new row 2. Right? Wait. Okay, let me. All right. So I'm going to leave row 1 alone. 1, 2.3, 2.1, 0.1, 0, and 0. That's going to be problematic later, I'm afraid. So minus 11 times row 1 plus row 2. I know what the first one is. 0. Good. All right. The next one gets to be a problem. So pull out your calculators. Negative 11 times 2.3 and add to that 26. And what do you get? 0.7.
Yes.
Okay. And negative 11 times 2.1 plus 24.
Zero point nine.
0.9. Okay. Next, I can do this one, I think. Negative 11 times 0 plus 0.1. 0.1, isn't it?
Oh, yeah, I thought it was that. What you say was, oh, it was 0.1, not 0. I thought it was, you said 0.
What's that again?
No, I misread it.
Okay. All right. And then negative 11 times 1 is negative 11. So that's negative. Oh, I'm sorry. Times 0. You're right. So that's just 1. Okay. Let me get my pen back. Okay, that's a 1. And then negative 11 times 0 plus 0 is 0. I can do that one. Okay, safely. All right.
We can also do negative 12, row 1.
Negative 12, row 1, plus row 3. Okay. All right, and here's Daniel. All right. We go over these real quickly again. I think you have many-term PE classes, don't you? Yeah, and you know today's the last day for them, right? Yeah, okay. Have you done student course evaluation for them? Okay, good. All right. I'll make sure everybody knew to do that. Also, and you've heard this before in the other class, because midterm is tonight at midnight, sometime after midterm, they ask for student course evaluations. Okay, not student course evaluations, midterm progress reports. And midterm progress reports means I have to report anyone who doesn't have who has a D or an F at midterm, right? And if I don't have anything on the books, which for all three of you here, I have nothing on the books for this course, so please get me something either Thursday or the very latest Tuesday. But remember also, Friday I'm not on either campus, so you can't leave something you can leave it on this campus under my door, but I won't get it Friday. I won't get it until Monday morning. Okay? But that should be time to get the things in. I haven't heard if they've announced when these are due and when that's going to be, but if they do, I have to have them in. So please get me something sooner rather than later. Either the research paper or your first test, one or the other. Okay. I think, and then next Friday, I have a doctor's appointment across the street here, eye doctor, at 8:15. So as soon as I get out of that, I'll be heading back to Birmingham West. So I probably won't get there much before 10. So I don't know, but I'm guessing that. All right, we're doing this problem here. We're taking the inverse of this matrix here that we got by multiplying those two matrices together. And we're doing the inverse, and we did the first step there by dividing by 10, first row by 10. Then we did the second row. So we wrote down the first row. The second row, we did minus 11 times the first plus the second. And we're just about to start minus 12 times the first added to the third. So tell me what this will be. Minus 12 times 1? Minus 0. Good. Minus 12 times 2.3. Calculator time.
0.6.
Okay, this is 0.3.
6.
3.6. Is that what you said?
Yes.
Okay, let me get that cleaned up because if I can't read my writing, I'll make a mistake. Okay. And then minus 12 times 2.1 and add that to is what? 1.2.
0.
Nope. Okay, minus 12 times 0.1 is minus 1.2.
Oh, yeah, I skipped one.
Okay. Yeah. The next one is a 0. I'll agree with that one. And the next one's a 1. Got it. Okay. Now, what do you want to do next?
Now I'm confused for a second. Both of the second rows, we want them to be leading at 4 with 1. But I see all of them leading with 0.7, 0.6, or whatever. That's not. Now, for here, you got me lost. You got me confused. You got me want to give up. Because I want to lead in 1, and I'm seeing less than 1. So, should I give up? Or is it
You could still divide this by 0.7, and that would be a 1. Right?
Okay.
0.1, 0.7 divided by 0.7 is still 1. Even though it's less than 0, it's still 1. This divided by 0.7 will come out with a bigger number, so that's okay. But rather than doing this one, I want to do this one. You see why? At least these 3 are going to be, and this one are going to be nice numbers, and that won't be too bad. This one, all 3 of those will be, all of those are going to be pretty ugly fractions. Okay? So I want to do this so they're not quite as ugly. Is that okay?
Yes.
Okay. So what I want to do is flip these 2 rows, which is legal. We can do that, remember? All right. So I'm going to flip the 2 rows, keep the top row the same. 1, 2.3, 2.1, 0.1, 0, and 0. And then the new second row will be 0. Can I go on and divide by 0.6 at the same time? So that'll be a 1. This will be a 2. This will be a 2. This will be a 0. And this will be... Oh, yeah, the second. Yeah, I'm sorry. You're right. Okay. Now, that last one is a pain. I'm going to write it as 10 over 6, which is 5 over 3. I know we did decimals before, but this one is much easier to do as a fraction. So you see what I'm doing is 1 over 0.6 would be the same as 10 over 6. 10 over 6 is 5 over 3. Okay? Please say yes. Okay. All right. Now, what I'll do then is write down what was the second row to this one. So, I haven't done my little marginal notes, but I hope you know what I'm doing. 0.7, 0.9, 0.1, 1, and 0. All right. Now, what I think I'm going to do now is erase a whole bunch. So hopefully you got all this written down. I don't think I need A and B anymore, so I'm going to erase those. Is that okay? I sure hope I don't need them anymore because I'm erasing them. I can get them from the book because those, I know what they are. Okay. All right, and I'll erase this line. Okay, and I'll even erase this one because I don't think I need that either. Leaves me more white space to play with. All right, but I'll leave that one. Yeah, yes. Okay. Now, what's the next step?
One was 0.7 times row 7, -7 times row 2 plus row 7.
Add it to row 3. And we'll also be multiplying row 2 by negative 2.3 and adding to 1. See, this we're doing Gauss-Jordan elimination. Remember, what we want is not just Gauss elimination here. We've got to have both because we need to have these first 3 columns to be an identity matrix at the end. So we have to do Gauss-Jordan. We have to eliminate both above and below. It's so much fun, I know. Okay. Restrain yourself, okay? All right, so what we're going to do here, just because I like to start with row 1, you don't have to, is minus 2.3 row 2 plus row 1. That should give it to us, right? All right, so I'm going to write down the middle row, 0, 1, 2, negative 2, 0, 5/3. 5/3 is going to be so much fun. All right, so negative 2.3 times 0 is 0. Added to row 1 would be 1. Good? Next. 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 It better be 0, hadn't it? Yeah, and it is, right? Okay. Now, this one takes some effort. Negative 2.3 times 2 would be negative 4.6 plus 2.1 would be a negative 2.5, I think. Am I right or not?
You said 4.6.
Negative 2.3 times 2 is negative 4.6 plus 2.1, I think is negative 2.5. Yay or nay? Okay. Yay! Okay. Negative 2.3 times negative 2 would be positive 4.6 plus 0.1, that would be 4.7. Right? Is that right? And I think I can do this one. Negative 2.3 times 0 is 0 plus 0 is 0. Whew. Okay. And then the next one, this is the pain. Negative 2.3 times 5 divided by 3 plus 0. So this is going to be a pain in the neck. I think I want to leave it as a decimal. So what this will be, that would be negative 11.5 divided by 3. That would be what a pain in the neck. Let's just leave it like that. Minus 11.5 divided by 3. I hate that, but let's not mess with it anymore. Make sure I did that right. I believe I did. Okay. Now,
You was making it to a decimal. I have negative 3.8.
negative 3.8333333, yeah, right. The only reason I want to avoid the repeating decimal is we might need that later. So it's ugly and weird looking, but I'm going to leave it like that for now. Okay, and down here we'll do, as you said, negative 0.7 times row 2 and add it to row 3. Okay, and what will that give us? A 0 there. Better get a 0 there. All right, negative 0.7 times 2 would be negative 1.4 plus 0.9. Say negative 0.5, I believe. Check me on that, is it? Negative 0.7 times 2 would be negative 1.4 plus 0.9, I think is a negative 0.5. Negative 0.7 times 2 is negative 1.4 plus 0.9, I think is a negative 1.5. Is that right?
Yeah.
Is it? Okay. All right. Negative 0.7 times a negative 2 would be a positive 1.4 plus 0.1 would be a 1.5. This is looking much nicer. Okay? And negative 0.7 times a 0 plus 1 is just a 1. And negative 0.7 times a 5/3, I believe, is going to be a negative 3.5 over 3 plus 0. All right. Oh, that's not what I want. I just did something dumb. I've got to get it back. Okay, there, I got it back. Okay. Have I done something wrong? All right. Now, y'all got it figured?
Yeah, for 1.5, the positive one.
This one?
Yes.
Okay. How do we get that?
Yes.
Negative 0.7 times negative 2. That's negative 1.4, I think.
Yes.
And then add a 0.1 to it. It's a positive 1.4. Add a 0.1. Yay or nay?
Yeah.
Now, what's the next thing we want to happen? Just a quick review here. We got a 1 up here, 0 below it. You got a 1 here, 0 above and below it. What's the next thing we want? We want that to be a 1. How do we get that to be a 1?
Times negative 5.
Do what?
Negative 5 to row 3.
Do what? Say.
Multiplied by negative 5.
No.
I mean, divided by negative 5.
Negative 0.5. Okay, how about this? Multiply it by negative 2. Does that work?
I prefer negative 5.
You want to divide by negative 5 rather than multiply by 2.
0.5, yes.
Okay. I'll go, you do that, I'll multiply by negative 2, okay?
I did it. It gave me 1, negative 3, negative 2, 2.24.
Okay. Let's see what this becomes. We're just doing this. So I'm going to do negative 2 times row 3. Okay? I'm going to write down the first two rows. 1, 0, negative 2.5, 4.7, 0, and negative 11.5 thirds. That's ugly. A 0, 1, 2, minus 2, 0, 5 thirds. That's sort of ugly. And this one will then be multiplying by negative 2. A 0, 0, 1, negative 3, negative 2, okay. I'm going to write it this way, if that's okay. I'm going to write as a 7 thirds. Is that okay? All right. Now that is really crowded over there, but I think we got what it is. All right. Now what's the next thing we're going to want to happen? Zero above that 1. Okay. So how will we make that happen in the first row? Right? .5 times this added to that. That should do it, right? Right? Okay. So let's do that. So that would be a 1. I'm using the second row. No, I'm using the third row. 0, 0, 1, minus 3, minus 2, and 7 thirds. Okay. Strange but true. Okay. So this will be a 1. That'll be a 0. And this will be a 0, too, I hope. Right? All right. And 2.5, okay, do it on the calculator. 2.5 times negative 3 will be a minus.
2.8.
Say again?
Negative 2.8.
I don't think so, is it? (2.5) times a negative 3. Oh, you went on and subtracted 2, or multiply. Negative 2.8. Okay, I'll take your word for it. I hope you did it right. Okay. Then 2.5 times a negative 2 will be a negative 5. And what is that up there? A 0. So that's just going to be a negative 5, isn't it?
Yes.
Okay. And then a 2.5 times a 7/3.
1.7664.
Okay.
I got the decimal.
And you added it to minus 11. Okay.
Yes, I got decimal. I got 1.7667.
Once you added it to the minus 11.5 thirds too?
Yes.
You did.
Yes, but I got decimal.
Okay. Let me try it in this and see what I get. 2.5 times 7 will be a 15, no. Goodness, where's my head today? That's 35. 17.5? 17.5 thirds.
I got 1.7.
No, I don't think so. Wait, let me see. Because 2.5 times 7 is more than 1, okay? It's 17.5, I think. And subtract from that 11.5 thirds, and I think you get 6 thirds, don't you? Which is a 2.
Are we subtracting or adding?
What's that?
Are we subtracting or adding?
I still can't hear you.
Are we subtracting or adding?
Well, this is a positive, and we're subtracting that from it. And this is 17.5 thirds minus 11.5 thirds, and that would be 6 thirds, which is 2. Is that right? Okay, I hope it is. It looks nice anyway, okay? All right. So, let's get my scratch out. Oh, no, I keep doing the wrong button. Okay. Erase my scratch. Ooh, my eraser didn't come up. All right. Okay. Now, middle row. Looks like to me a minus 2 times row 3 plus row 2. That should do it, shouldn't it? That'll be a 0, 1, sorry. Okay, 0. All right, now the hard part. Minus 6 minus 2 is minus 8. Right? I hope I did that. Yeah. And then you got a 4 plus 0 is 4. And then let's see what we get here. Minus 14 thirds plus 5 thirds is 9 thirds, which is minus 3, I believe. Okay. I don't even know which one we're doing here. Okay. All right. Except for an error in the first row, we're okay. I think. No, we're not.
Yeah, I'm happy. I got different things.
Okay.
Okay, can you check what I have is if this one doesn't have also?
Okay, what do you have?
I have a first row
You have what?
Like the first row.
Fourth row.
The first row.
Oh, first row.
Dictate what I have.
Okay.
I have 1, 0, 0, negative 2.8,
Right.
negative 5,
Right.
1.7667.
1.7227.
667.
627.
Yes.
Okay.
And second row,
Yeah.
I have 0, 1, 0,
Right.
4.
4?
Yes.
For what?
4.
2 fours or 1 4?
Yes.
4 4.
Yes, and then negative 2.88.
2.88. Okay. Next.
And then third row I got 0,
Right.
0,
Yep.
1,
Right.
negative 3,
Negative 2.
no, negative 3,
Negative 3.
negative 2,
Negative 2.
and 2.24.
2.24.
And that's what I'm having.
Okay. Now, let me.
That's what the book have as well, or
Okay. Okay.
I ain't gonna interrupt your class.
What's that?
I said I'm not gonna interrupt your class.
Okay. Well, you know, the delay is the last day of class. Okay. I got to have all the labs in, all the tests completed.
I didn't do the test A or the final.
Right?
And I'm just gonna wait the class over with.
You're going what?
I'm waiting for your class to get over with.
Okay. Yeah.
Yeah.
Okay. Yeah.
I'll be here.
Okay. All right. Now, let me tell you what they have. We agree on the first part, the identity matrix. So let's do the second part. What they have, and you had the same thing I did here, right? Okay. They have an 8. I don't know where I made a mistake there. They have an 8. But then the -5, and then they had a -2. You had a plus this. It should be a minus if the book is right. Then the next one was a -8, just like I had, not yours. A 4, just like I had, not yours. And I had a -3, they have a +3. So evidently I have a sign change wrong in that one. And then they have a 5. We both had -3s here. They have a 5. Then a -2, that's correct. And then a -7/3. So I had my last column off by a minus sign. And that probably threw everything else. So I was pretty close, but it was a pretty bad mess, okay? Now, they did it a slightly different way, but they didn't show how they got A inverse. They just said, given the fact that A inverse is this and B inverse is that, well, where did they get those? You know, they had to do them, but they didn't do them. They just left that for you to do. So obviously made some dumb errors here, but we weren't far off, okay? A little more care with the placement and stuff like that will work. But I think you might see from yours that when you do decimals and round too soon, those round-off errors grow on you. Because you came up with a 1.76, that should have been a 2, not a 1.76. And you came up with a 2.88, it should have been a 3. So your round-off errors grew on you. And you came up with a 2.24, and it should have been a 2.33. So it wasn't bad on the last one, but it was a little bit of one, okay? So the round-off errors do grow, and that's why I was wanting to leave it in fractional forms to keep from doing the round-off errors. But I knew automatically when I was getting some of those weird numbers, like the 2.8, I knew I'd made a mistake there. There had to have been some error there, and there was. Okay, but enough of that. We're not going to go back and find the mistakes because I've already erased most of them. Okay, so when you get bigger than 2 by 2s, you got some work on your hands. It's not hard work, but it is work and time consuming. And you have to be very careful with adding and subtracting and multiplying and stuff. All right. Now they mention at the end of this problem, it has nothing to do with that problem. One important property in the algebra of real numbers is the cancellation property. That is, if AC is equal to BC, as long as C is not equal to 0, okay, then we can say that A is equal to C. invertible matrices have a similar cancellation properties, and here's what theorem 210 says. If C is an invertible matrix, now tell me something that means. If C is invertible, what must C be? Square. It's got to be square. Okay? Now that won't prove it is, but it's got to be square. Then the following properties hold. Okay? Here's the first. If AC is equal to BC, then A is equal to B. Now, if you recall earlier, you couldn't always say that. But now you can if you know C is invertible. Okay? If C is an invertible matrix, then this is true. Okay? That's the right cancellation property. The second is this one. If CA is equal to CB, then A is equal to B. Okay? So you can do it either from the left or from the right, but you can't reverse it. Okay? You can't say if CA is equal to BC, divide out the C. No, you can't do that. Okay? But you can if it's multiplied on the same side. And part of the reason for that comes in the proof. And we already know C is invertible, so therefore let's multiply both sides by the inverse. Okay? But then this thing right here is the identity matrix, and this is the identity matrix. And IA is equal to IB, and IA is just simply A, and IB is simply B. So yeah, they would have to be equal. But you can't necessarily go the other way, because A and B may not even be of the right size to do it the other way. Okay. They did the first one, I did the second one. Okay, in the proof. All right. I think we're out of time, aren't we? Or awfully close.
Yes. 3 minutes, I think.
No, that's right. I'm sorry. Wait, how many minutes you say?
2.
Oh, 2 minutes. Okay. Let's see if we can get the top part of the page done. Well, let's just start at the top part of the page. I think we might be able to get it done, but let me just make a mark here. We'll start with systems of equation at the top part of the page. But let me give you homework exercises here. You can do any of the odds 1 through 5. Do any of the odds 7 through 29. There's a whole bunch of those there. You can do any of the odds 31 to 35. All these are at calcchat.com, by the way. You can do any of the odds either 37 or 39 or both. And then you can do any of the odds 41 to 44. And stop there. We'll pick up the rest of those next time. That probably used most of my time, didn't it? Okay. So, any questions? You see, you have to be very careful, slow, diligent, and careful with your calculators too when you're doing these. And to keep from having round-off errors, in that first one, dividing by 10, it was just so easy to do that as decimals. But then later, when you're dividing by 3s, that's not going to work as well. Okay, so be careful. All right, I'm going to shut this down then.